morning students. In last class we have done about the valence shell electron pair repulsion theory, and this is one of the theory from which you can explain about the structure of different molecules. Generally those molecule in which the central atom contain lone pair, then for that type of molecule you don't get the regular geometry for the compound. It will adopt some different shape, and that shape you can explain by applying valence shell electron pair repulsion theory. In last class I have given one table. Actually the structure of a compound depends on the total number of electron pair inside the central atom. Depending on that you can find out the structure, and it depends on whether the electron pairs all are bond pairs or it contains some lone pair also. So based on that I have given one table. You can find out the, for example, if I ask you, this is one of the molecule H2S. What will be the shape of this molecule? This is called hydrogen sulfide. What will be the structure of this molecule? To find out that, your central atom is sulfur, and as you know sulfur contains 6 electrons in the valence shell, 1 2 3 4 5 6, and there are 2 hydrogen present. So one hydrogen is this one, another hydrogen is this one. Sulfur carrying 6 electron, that's why it requires 2. So 1 electron take from hydrogen, hydrogen take 1 electron from sulfur. I mean sharing of electron takes place like this. So after sharing you will get 2 bond pair and 2 lone pair. That means the central atom contain 2 bond pair and 2 lone pair. So I have given the table. If the central atom contain 2 bond pair, 2 lone pair, then what will be the shape? The shape of the molecule will be band shape. So from the table you can find out the structure of of different molecules. So H2S structure, if you want to write, then you have to write like this, which is called the band shape. Now about the angle. If you want to know about the angle, this is your H2S and this is your water, H2O. As you know, oxygen also carrying 2 lone pairs, 2 bond pairs. That's why both have the band shape. But in both water and H2S, the central atom oxygen and sulfur both undergo sp3 hybridization. So sp3 hybridization produce tetrahedral shape, but here you don't get tetrahedral shape due to presence of lone pair, and that's why it will adopt the band shape. Now what about the angle? The bond angle, when it undergo sp3 hybridization, the bond angle should be 109.5 degree. This is the tetrahedral bond angle. But since they do not have the tetrahedral shape, since they are bent, so you don't get the angle 109.5 degree. Now the angle will be less than 109.5 or more than 109.5 degree. Now here you have seen there are 2 bonds present, and the angle between these 2 bonds, that is called the bond angle. So this bond angle will be more than 105 or 109 or less than 109. If you want to find out that, since 2 lone pair are present, so some lone pair repulsion takes place, and due to this lone pair repulsion, the bond come closer to one another. So when the bond come closer, then the bond angle going on decreasing, and that is why in both water and H2S, due to lone pair repulsion, the bond angle decreases from 109.5 degree. So now normally in water the bond angle is found to be 104 degree. I mean how much less from 109? Actually it should be 109, but due to lone pair repulsion it becomes 104 degree, so 5 degree less here. In case of H2S also, due to lone pair repulsion, due to this lone pair repulsion, the bond angle here also decreases from 109.5 degree, and experimentally it is found that the bond angle is only 92 degree. See, in both the molecule, the central atom contain two lone pair, two bond pair, two lone pair, two bond pair. Here also lone pair repulsion takes place. Here also lone pair repulsion takes place. But the angle is not same. In water, bond angle decreases by 5 degree from 109 and it becomes 104. But here bond angle decreases more. It is how much? 92 degree. Why? If you want to explain this, so that is why bond angle do not depends on the number of lone pair and bond pair inside the central atom. It depends on another factor also. So I will tell you, here lone pair repulsion takes place. Here also lone pair repulsion takes place. But although both the molecules are same, both the molecules contain same number of bond pair, same number of lone pair, here central atoms are different. Here central atom is oxygen, here central atom is sulfur. And due to different central atom, you know oxygen is more electronegative than sulfur. Due to more electronegativity of oxygen, what is electronegativity? Electronegativity means it is the power of attraction towards the shared pair of electron. So here these are the shared pair of electron, here 2 electron present, here 2 electron present. Since oxygen is more electronegative, so it will attract the shared pair of electron towards itself. I mean towards oxygen the bonded electron goes due to electronegativity. So when the bonded electron goes towards oxygen, then the bond pair become closer. When the bond pair become closer, then some bond pair repulsion takes place. Electron pair always have the repulsion. You know the repulsion, lone pair repulsion, lone pair bond pair repulsion, and bond pair repulsion also may take place. So here due to closeness of bond pair, so bond pair repulsion, suppose these two are bond, this is bond pair, this is also bond pair. So when they are closer, bond pair repulsion takes place and the bond far away from one another. So that is why here also the angle should be 92, but due to this bond pair repulsion, the bond cannot come very close to each other, and that's why here angle is 104 degree. I mean it decreases less. But in this case, you know sulfur is less electronegative, so it cannot attract the bonded electron towards itself. That's why bond pair becomes far away from one another. That's why here bond pair repulsion is less. When bond pair repulsion is less, then the bond may come close to each other, and that is why here angle decreases more and the angle goes to 92 degree. So what is the conclusion? The conclusion is, if the electronegativity of the central atom is more, you will get angle more. If the electronegativity of the central atom is less, angle you will get less. So it depends on the nature of the central atom also. It not only depends on the lone pair and bond pair, it depends on the nature of the central atom also. So although both the compounds are same, but their bond angles are not same due to this electronegativity difference. And that is why the question asks, in water the bond angle is 104 degree, but in H2S the bond angle is only 92 degree. Why? Although the central atom contains same number of lone pair and bond pair. Then you have to explain by considering the central atom. Again, another one, these are the questions, reasoning questions which may ask from this Vesper theory. This is NH3, which is called ammonia. It contains one lone pair. And this is NF3, which also have one lone pair. Although both the molecules are same, but their angles are not same. Here nitrogen and hydrogen is present. You know nitrogen is more electronegative, that's why electron will attract by nitrogen. Here between nitrogen and fluorine is more electronegative, so electron will be attracted by fluorine. So here bond pairs are closer, that's why bond pair repulsion takes place. Here bond pair are far away from each other, that's why repulsion will be less. Since bond pair repulsion takes place, I mean central atom is more electronegative, that's why angle become more. I mean bond angle of NH3 is greater than NF3 due to this electronegativity difference. Since the electronegativity of the central atom is more, that's why bond angle will be more due to bond pair repulsion. but here no such bond pair repulsion takes place because the bond pair are far away from one another. Surrounding atom attract the bond pair, that is why bond pair are far away from each other, and due to less bond pair repulsion, bond may come closer, angle going on decreasing. Thank you.